afford a universal flood because that would destroy all terrestrial life on Earth, terrestrial life, and the whole evolutionary process would have to start from point A, but since it needs its origin right at the base of the column, that would be a major problem. History would have to repeat itself a second time over. So obviously they might conceive of a local flood, but a universal flood, forget it. Now, if we look at this geological column, there are some very interesting features. Here is the geological column based on its periods, and up there is the tertiary layer where we have the mammals and the birds and all the creatures that we see today. But there's this interesting layer underneath which is called the Cretaceous. Now that's an interesting layer. Let's have a look at it in somewhat more detail. Here you have the Precambrian layers, then you have the Paleozoic, starting with the Cambrian. That's where all the first macro life forms came into existence according to the theory. Then you have the Triassic, then you have the Jurassic, and remember those who saw the movie Jurassic Park, that's when what lived? All the dinosaurs supposedly, and then something happened, and they were all gone. And science calls that the KT boundary. The Cretaceous, in German it's Kreide, chalk layer, Kreide with a K, K, tertiary, T, KT boundary, and here you have massive extinctions, and then you start with the top layers. Now, Cretaceous, what does that mean? Why is it called the Cretaceous layer? Well, it's called the Cretaceous layer because it consists of marine organisms. Here you have all these interesting suppositions of what this Cretaceous could have looked like with all these interesting marine creatures floating around. And in some areas, you can see this layer very prominently, like here at the White Cliffs of Dover, for example. You have this massive chalk layer. And in other areas of the world, you have a relatively flat chalk layer. Now, what does this chalk consist of? And remember, this is the layer we're talking about in the geological column. This is what it consists of under the microscope. If you put it under the microscope, you see all these microscopic bodies of algal skeletons consisting of calcium carbonate. Here are some more organisms. These are foraminifera shells. These are tiny little unicellular creatures in the ocean that consist of calcium carbonate. Foraminifera are tiny little unicellular organisms. This is basically what you'll see in the Cretaceous. All these marine organisms, all these shells, and all of this can only happen where? In water. Only happen in water. There's something else that's interesting. There's a layer over here in the Bighorn Basin where you have the Mesozoic, Paleozoic layers underneath, and then you have a Cenozoic layers on top. That's the young ones. So the boundary we're talking about is over there, on that line over there. That's where you would find chalk deposits. Now, what happens to form chalk? How does chalk form? Well, you see, these marine organisms, when they settle down, when they die, and the organic material disappears, all that remains is this calcium carbonate shell. And that settles down and forms then a white layer. Does it happen today? Yes. Why are our ocean basins not full of chalk? Because the oceans are so deep that as these materials form, they dissolve on the way down and nothing hits the bottom. Are you with me? But if you were to go diving in the mid-Atlantic ridge, under the ocean, where the mountain tops are very high, on top of each of those mountains, under the Atlantic Ocean, on top, you would find a chalk layer. So it looks like you're swimming in the Alps, white-topped mountains. Really great. So how did that happen? You see, the ocean has to be shallow for the chalk to form. So this ocean that existed had to be a relatively shallow ocean. And how far did it extend? Now, the Cretaceous layer is the one layer that is universal. Now, take note. The Cretaceous layer is the one layer that stretches from continent to continent. And in some areas it's thick, in other areas it's less thick, but it is universal and it covers every single continent. And it's on the same base rock. So my question to you is this. If that layer is universal, it tells us one thing, and that is what? That the whole world must have been underwater at the same time. And if that is a fact, then we can really stop this lecture right now. The deal's done. Then there was a universal flood, and that is